Alright, so it's entirely possible to do these things by hand. Um, as I saw, you may or may not have seen in that last video. Let's look now how we would do it on the calculator. So we're doing first the TI-83. We need to somehow tell the calculator what this matrix is. You'll notice that in this calculator it might be kind of hard to read, but in yellow right here it does say matrix. I guess it's missing an I, but whatever. If I press the second key, because it's in yellow, I press the second key first and then press this, you'll notice it brings me into an area here where there's a bunch of letters surrounded by brackets. And there's, similar to what we saw before, there's three different tabs here. Let me scroll through these. There's names, math, and edit. Both names and edit just list off, well, these are names of matrices. These are all the different matrices this calculator can hold on to at the time. We're not really going to be dealing with more than a couple of matrices at a time, so we don't need to use the rest of those. But what the difference between the names and the edit menu here, tab, I guess not menu, whatever. The edit tab allows us to go in and change what this matrix is. So if we're looking at matrix A here, or you can see I'm in the edit area, and I select A, or it's already selected, and then I just press enter. What this will allow me to do is to set up what matrix A represents. This is, remember that matrices are the number of rows by the number of columns. So this is a 3x4 matrix, so I'll go ahead and say 3x4. And you can see it kind of set this up already. There's 3 rows and 4 columns. Well, you can't really see that 4th column, but if I scroll over, you can see it. And then I can just go ahead and put in all the various, put in these values. And to put them in, what I'll do is I'll just type in what it is, 0 in this case, and press enter. And as soon as I press enter, you can see it moves me to the next cell. It moves me to the right. This is just like if you're reading, it moves left to right, and then once we get to the end of this row, it'll bring us down to there. So in any case, 0, 1, enter, 2, enter, 3, enter. As soon as I hit 3, it brings me into that second row, and I can continue typing. So I'm just going to do this with my, oops. Oh, if you haven't seen this already, the mistake I just made here is I was using my keypad to type into this calculator, which is essentially the same as the minus key instead of the negative. So I should have -2, not -2. It confused the calculator there for a minute. So -6, -10, and -12. Again, hitting enter between each of these. 2, 1, -2, and -5. Enter. And there we go. So now this calculator has this same matrix stored. What we can do is we can quit out. So again, kind of like what we saw before when we were dealing with the scatter plots and doing that. We can quit back to the home screen by pressing second and then mode. So I press this button and then this one. That's how I quit out. You can verify that the calculator actually does have that remembered. So if I go back into the matrix area here, second and then this button, you can see now matrix A is now stored as a 3x4 matrix. Let's look to see what happens when we call up, when we access this particular matrix from the names menu. If I was to press enter right here, what it does is it brings A, that matrix, and it brings it to our home screen. This is the place where we can normally type, where we normally do other things. So if I just type A here and leave it by itself, you can see it just outputs the matrix that we were just dealing with, that we just input. Alright, so that's matrix A. What we're actually interested in doing right here is we want to go into math, and we want to use a function called RREF. So to get there, what I'm doing here, you could scroll down a ways, or what I tend to do is I tend to just scroll up a few times because it wraps around. And in any case, the function we're looking for here is called RREF. So we would take this matrix, store that in A, then we're going to run RREF on that matrix A. We want to tell it to run that function. So these are functions just like we saw, the other functions. This is telling us what the input is. RREF is the name of the function that's going to be running. So RREF, we want to tell it to run on function A. You can see there's a parentheses opened up. We want to put this matrix in there, and so we do that by going to the matrix area, the names here in the matrix area, and so I'll select A there by pressing enter, and you can see it put this here. I'll go ahead and close up my parentheses so it knows that this is all of the input. So this is going to run this function, REF, on that matrix. It stands for reduced row echelon form. We don't really need to know that, just RREF is the... You do want the one with two R's, though. Don't just do the REF. You want RREF. Reduced row echelon form, not just row echelon form. So you can see by doing that, it actually spits out an answer here. This spit out 1, 0, 0, negative 2, 0, 1, 0, 1, 0, 0, 1, 1. And if you watched the Gauss-Jordan method, the last one, you would have noticed that that is the same solution we found before. This right here says that the point negative 2, 1, 1 satisfies the system of equations that's represented here. This would be an x, y, and a z coordinates. So if we're looking at each of these equations, 0x plus 1y plus 2z equals 3. This is what the first equation says, 0x plus 1y plus 2z equals 3. You can check to make sure that it satisfies each of these equations. You don't really need to do this at this point, but I'm going to anyway. Let's see, 0 times x, well, I don't need to write that. 0 times negative 2 is 0. Plus 1 times 1 is 1. 2 times 1 is 2. Plus 2 equals, of course, 3. So this is 1 plus 2 equals 3. So it satisfies the first equation. If we wanted to check to see if it satisfies the second equation, this is supposed to be a 1. I'm just checking to make sure that everything worked out here. Negative 2x minus 6y minus 10z equals negative 12. This is the second equation. Negative 2x minus 6y minus 10z equals 12. When I plug stuff in here, negative 2 times negative 2 minus 6 times 1 minus 10 times 1 equals negative 12. I'm going to go ahead and plug that into the calculator since I have it here. 4, that's the negative 2 plus negative 2, or times negative 2 rather, minus 6 minus 10 gives us negative 12. So this one checks out. And for number 3, 2x plus y minus 2z equals negative 5. Plugging in the point negative 2, 1, 1. Let's plug that one into the calculator as well. This is negative 4 plus 1 minus 2. And that gives us negative 5, which is what we expected here. So that one checks out as well. You can see all three of these equations are satisfied by this point. And this is the one equation, the one point rather, that does satisfy all three equations. We know that because we ended up with this 1s along the diagonal and 0s elsewhere on the left-hand side of our augmented matrix.